Assalamu alaikum my dear students, hope you are well by the grace of Almighty Allah. Welcome to NIBS Home School. This is Muhammad Emdadul, Assistant Teacher of Mathematics, National Ideal English School, Reship. Dear students, today I am going to conduct a higher mathematics class of class 9. Okay dear students, our today's topic is exercise 8.2 basic discussion and problem 6. Here two problems we have to solve from question 6, 2 and 4, and problem 7 we have to solve. Okay, and this is our lecture 30 and homework now is 23, and our today's homework is given from exercise 8.2, example 16 is our homework. Okay dear students, let us see at first what we will learn in our today's class. When I will complete our today's class, we will be able to learn trigonometric ratios of acute angle, relation of trigonometric ratios, trigonometric identities, trigonometric ratios of any angle, sign of trigonometric ratios in different quadrants, values of trigonometric ratios of angle 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Solving problems, and I have written the problems here. I will solve this problem after the basic discussion. Okay dear students, so at first I am going to discuss trigonometric ratios. Dear students, in general math you have learnt also trigonometric ratios. Just to look through. Suppose PQR is a right angle triangle where angle P is right angle, or we can write here PQR is a right angle triangle where angle Q is a right angle. So we know the opposite side of angle right angle is known as hypotenuse, and if we consider angle R as theta, adjacent side of this angle except hypotenuse is known as base, and the side opposite to the angle theta is known as perpendicular. So we can write here perpendicular, or we can this is opposite side, we can write. Okay dear students, so we know three names of three sides of a right angle triangle. Now we are going to discuss the ratios of trigonometric ratios. It means ratios of these three sides in trigonometry. We can write in which way we will learn now. At first I want to determine the ratio of perpendicular and hypotenuse. So we can write here perpendicular and here is hypotenuse. Here perpendicular means PR. Here hypotenuse means, perpendicular means PQ. Hypotenuse means PR. So PQ by PR. This is the first ratio. The ratio of perpendicular and hypotenuse is known as, in trigonometry, that is known as sine. The full form is sine of angle theta. In short we can write sine theta. Then we will go to the next ratio, that is the ratio of base and hypotenuse. So we can write here base and hypotenuse. That will be known as, here base is QR, hypotenuse is PR. That is known as cosine of angle theta. In short, we can write here cos theta. Then we will go to the next ratio of perpendicular and base. So we can write here perpendicular and base. That is, perpendicular is PQ and base is QR. So that is known as tangent of angle theta, tangent of angle theta. In short, we can write tan theta. Tan theta. Here theta is an acute angle. Okay. So we are going to write the opposite ratio of this ratio now. So what will be the opposite ratio of this one? Perpendicular ratio base. So this will be base ratio perpendicular. Base ratio perpendicular. That is known as base ratio perpendicular, means we can write here base is QR, perpendicular is PQ, so we can write this as cotangent. In short, we can write here cot theta. Then next ratio is opposite of base ratio hypotenuse, so this will be hypotenuse ratio base. So here is hypotenuse is PR and base is QR. This ratio, hypotenuse ratio base, is known as secant of angle theta. In short, we can write sec theta. Secant of angle theta. In short, we can write sec theta. Then the last ratio, that is hypotenuse ratio perpendicular. This is perpendicular. So we can write here this is PR means hypotenuse, PQ means the perpendicular. So this ratio is known as cosecant of angle theta. In short, we can write cosec theta. Okay, dear students, so we have discussed 6 ratios of acute angle. 6 ratios for acute angle I have shown here. Now we have done first one, now I will do the second one, relation of trigonometric ratios. Now I will show the relation among these ratios. Now see, dear students, sin theta means perpendicular ratio hypotenuse, but here if you notice the last one, hypotenuse ratio perpendicular, so this is opposite. So we can write sin theta equal to 1 by cosec theta, and we can say here this one is base ratio hypotenuse, but this one hypotenuse ratio base, so these two are opposite, so we can write here 1 by cos theta is equal to 1 by sec theta. And see, tan theta means the opposite of cot theta, so we can write tan theta equal to 1 by cot theta. So conversely we can say now cot theta equal to 1 by tan theta, sec theta equal to 1 by cos theta, and cosec theta is equal to 1 by sin theta. And last two ratios we can write here tan theta and cot theta, we can express as sin theta and cos theta. I want to show here tan theta, or I can show here tan theta means we can write here sin theta by cos theta, and cot theta means cos theta by sin theta. So these are the relations among these 6 ratios. Okay, dear students, so I hope you have understood the relations. Now I will show trigonometric identities. What are the trigonometric identities? Now see, dear students, As we are writing the ratios or trigonometry is applicable for right angle triangle, you know, in case of right angle triangle, you know the theorem of Pythagoras, that is PQ square plus QR square. QR square is equal to PR square. It means this is the theorem of Pythagoras. Now if we divide this by PR square, what will we get? We will get here PQ square plus QR square divided by PR square. We will get here PR square by PR square. So what will we get here? PQ square divided by PR square plus QR square divided by PR square. PR square equal to this PR square vanishes each other, we will get here 1. Now we can write this as PQ by PR whole square plus this is QR by PR whole square. Dear students, here PQ by PR means PQ by PR, perpendicular by hypotenuse. This means sine. We have learned just before. So this is sine of angle theta means sine theta whole square plus, and this is QR by PR, it means cos theta whole square, that is equal to 1. Therefore we can write sine square theta plus cos square theta is equal to 1. Okay, dear students, here this sine square theta plus cos square theta equal to 1. This is an identity. This is an trigonometric identity. Now from this we can determine two other identities here. We can determine the value of sine square theta. Sine square theta equal to 1 minus, we have to shift cos square in the right side, 1 minus cos square theta, and we can write this as, if we want to determine the value of cos square theta, that will be 1 minus sine square theta. Similarly, we can determine other two identities here. The identities are sec square theta is equal to 1 plus tan square theta. Sec square theta is equal to 1 plus tan square theta. So from this we can write that is sec square theta. We can shift tan square in the left side. It will be minus tan square theta. That is equal to 1 in the right side. So this is another identity. That is, we can write this in this way. Tan square theta is also equal to, or we can write sec square theta minus 1. Sec square theta minus 1 is equal to tan square theta. Now I can write the another identity in the same process, that is cosec square theta. Cosec square theta is equal to 1 plus cot square theta. So from this we can write that is cosec square theta minus cot square theta is equal to 1, and that is, we can express this in another way, that is cosec square theta minus 1 is equal to cot square theta. We can write these three identities. So here is 3, here is 3, here is 3. So we obtain this 3 from only this one, this 3 from only this one, and this 3 from only this one. Basically, so we have three identities: sine square theta plus cos square theta equal to 1, sec square theta equal to 1 plus tan square theta, cosec square theta equal to 1 plus cot square theta. Basically, we have these three identities, and we can get these 6 identities from this tree. Okay, dear students, so I have discussed the trigonometric identities. Now I will discuss trigonometric ratios of any angle. Okay, dear students, so consider a plan xy. Here will be two perpendicular axes, x-axis and y-axis. Suppose here is a plane, that is x, o, x dash. Another is y, o, y dash. These two axes intersect each other at o perpendicularly. Now consider a ray OA along x, OA along OX, and if you revolve the ray OA, it will move anti-clockwise. It will move anti-clockwise and then produced angle with the positive direction of x-axis. It means with this direction. So for this, suppose the ray OA, the position of the ray OA is here, and consider a point P on it. Suppose the point P is XY. PXY be a point on OA. So we can draw a perpendicular here. So if we draw the perpendicular PM, here OM is equal to X and PM is equal to Y. And the produced angle consider as theta with the positive direction of x-axis. It means with OX, this theta angle will produced. Okay, dear students, so from this we can determine different trigonometric ratios. To determine the ratio, at first we can determine this. Suppose this is R, this is OP is equal to R. Suppose this OP is equal to R. So we can write here R is equal to root over x square plus y square, square root x square plus y square. As this is our right angle triangle, sum of the squares of these two will be the square of R, will be equal to the square of R, that is R equal to square root x square plus y square. Now we know this three sides of the triangle POM. So we can determine the trigonometric ratios now in respect of angle theta. Here theta can be any angle. So we can write here sin theta. Sin theta means we can write here PM by OP, that is equal to Y by R. Cos theta will be equal to here OM by OP. So we can say now cos theta equal to OM by OP means OM means X here, X by R. Now tan theta equal to PM by OM, that is equal to Y by X. Cot theta equal to OM by OP, that is equal to X by Y. Sec theta is equal to OP by OM, that is equal to R by X. Cosec theta is equal to OP by PM, that is equal to R by Y. So these are the trigonometric ratios for any angle theta. Okay, now I will show you the next topic, that is sign of trigonometric ratios in different quadrants. Dear students, if you notice here are four quadrants you have seen. This quadrant is known as first quadrant, this is known as second quadrant, this is known as third quadrant, this is fourth quadrant. Okay, dear students, now I will show you the sign of trigonometric ratios in all the quadrants. Okay, now if the ray OA is in the first quadrant, both the coordinate of x and y are positive. In second quadrant, here x is negative, y is positive. In third quadrant, x is negative, y is also negative. In fourth quadrant, x is positive but y is negative. So, if the ray OA lie on the first quadrant, what will be here? If the ray OA lie on the first quadrant, then in the first quadrant, sin theta will be, we have determined here, that is y by r. So, cos theta also will be x by r. It means that in this way we will get all these in the first quadrant. If OA lie on the first quadrant, it means all the trigonometric ratios will be positive in the first quadrant. So we can write all positive. In short, we can write all positive. Then in the second quadrant, quadrant x will be negative. So if we consider the ray OA in the second quadrant, here the point P will be minus x, y. So as here is minus x, y, if we calculate here, we will get sine and cosec positive. Rest will be negative. So in this quadrant, we will get sine and cosec positive. And in the third quadrant, if we calculate, we will get here tan and cot positive. In the fourth quadrant, we will get sec and cosec, cos and sec positive. So in the second quadrant, except sine and cosec, all the ratios are negative. In the third quadrant, except tan and cot, all the except these two, rest of the four ratios are negative. And in this fourth quadrant, except cos and sec, rest four ratios are negative. Okay, dear students, I hope you have understood the sign of trigonometric ratios in different quadrants. Now, values of trigonometric ratios of angle 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Just I will show the value in a table. Dear students, you have learned in general math how to determine the value. Just I will recall the values showing the table here. We will write here is ratio and here is angle. So I will write the angle here 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Here I will show the ratio. Ratio is sine, cos, tan, cot, sec, cosec. So I will show the values here. This is sine, cos, tan, cot, sec, cosec. Then here is 0 degree, or if it is expressed in radian angle, that is 0. And 30 degree expressed in radian is pi by 6. And this is 45 degree in radian will be pi by 4. 60 degree in radian will be in pi by 3. 90 degree, that will be is equal to pi by 2. So this may be given, angle may be given in both units, hexagonal system or in circular system, both may be given. If it is 0, sine 0 degree value is 0, sine 30 degree value is half, sine 60 degree, sine 45 degree 1 by root 2, sine 60 degree root 3 by 2, sine 90 degree 1, sine 90 degree 1. Then cos 0 degree 1, cos 30 degree root 3 by 2, cos 45 degree 1 by root 2, cos 60 degree is half, cos 90 degree is 0. Now tan tan 0 degree 0, tan 30 degree 1 by root 3, tan 45 degree 1, tan 60 degree root 3, tan 90 degree undefined. Cot 0 degree undefined, 30 degree root 3, 45 degree 1, 60 degree 1 by root 3 and 90 degree is 0. Now sec 0 degree 0, sec 0 degree 0, sec 30 degree, sec 30 degree is sec 30 degree, that will be equal to 2 by root 3, 2 by root 3, sec 45 degree, that is root 2, that is root 2, and sec 60 degree, that is equal to 2, and sec 90 degree is undefined. Cosec 0 degree undefined, and cosec 30 degree is 2, cosec 45 degree root 2, cosec 60 degree 2 by root 3, cosec 90 degree, that is 0, that is 0. Okay dear students, these are the values of different trigonometric ratios for angle 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Okay dear students, now I will show you how to solve the problems in this chapter. I will solve 3 problems from question number 6 2. At first I will solve question number 6 2. Okay dear students, so see the question number 6 2. I will solve. Here we need to show this is square root 1 plus cos theta by 1 minus cos theta equal to cosec theta plus cot theta. Cosec theta plus cot theta, that is equal to square root, that is equal to square root sec theta plus 1, sec theta plus 1 by sec theta minus 1. So this is the first side, this is second side or middle side, and this is third side. So I will show the second side from the first side and second side from the third side. So I will write here first side. First side is square root 1 minus 1 plus cos theta, 1 plus cos theta divided by 1 minus cos theta. Okay dear students, to solve this we can apply a technique here. What is the technique? The technique will be, we have to see here, we have to see the denominator, we have to see the denominator. We have to take the opposite one of the denominator. We have to multiply both the numerator and denominator by the opposite expression of the denominator. So here is 1 minus cos theta multiplied by 1 plus cos theta. So we have to multiply numerator also. Here is 1 plus cos theta into 1 plus cos theta. These two vanishes each other, so this will be equal to the given expression here. So we can write here, now if we multiply in the numerator we will get 1 plus cos theta whole square, as there are two 1 plus cos theta, it means 1 plus cos theta into 1 plus cos theta. Then we can write here 1 plus cos theta, 1 minus cos theta into 1 plus cos theta. It means a minus b into a plus b. It means a square minus b square, a square minus b square. So we can write here, now 1 minus cos square is sin square. We have learned from the identity of trigonometric ratios. Okay, now 1 plus cos theta whole square, here is sin square. So we can remove the square root from both the numerator and denominator. Only 1 plus cos theta will remain, 1 plus cos theta, and this square and square root will vanishes. this square and square root will vanishes, so we can write only sin theta here. From this we can write 1 by sin theta plus cos theta by sin theta. 1 by sin theta means cosec theta. We have learned this, and here cos theta by sin theta means cot theta. We have learned cot theta. Dear students, if you want, you can write the side note here. You can write the side note here. That is 1 minus cos square is equal to sin square. Okay, dear student. Now see, this is our middle side. Middle side, cosec theta plus cot theta. So now I have to show the middle side from the third side. How can we show? Now see the third side. Third side is square root sec theta plus 1, sec theta plus 1 by sec theta minus 1. So we can apply the same technique for this one. Sec theta plus 1 into sec theta plus 1 again. Now we can write here sec theta minus 1 into sec theta plus 1. So these two vanishes each other. The value remains same. We can write here sec theta plus 1 whole square in the numerator, and we can write in the denominator sec square theta. It means a minus b into a plus b, sec square theta minus 1. So we can write here sec theta plus 1 whole square divided by, we can write here sec square theta minus 1 is equal to tan square theta. We have seen. So if you want, you can write the side note here of the identity of tan square equal to sec square minus 1. So we can remove the square root from numerator and denominator, as here is square in numerator and denominator. So we'll get sec theta plus 1 divided by tan theta. So we can express now sec theta as 1 by cos theta plus 1 here, and here is tan theta means sin theta by cos theta. So take the LCM in the numerator. This will be cos theta, and here will be 1 plus sin theta, and here will be sin theta by cos theta. This means if we convert this as simple fraction, we can write 1 plus sin theta divided by I have written here sin theta. This should be cos theta. This should be cos theta. I have written here sin theta. If we do the LCM will be cos theta. So this will be cos theta. Now we can get here 1 plus cos theta, and here is cos theta, and we have to multiply this by, so this fraction we have to take the reciprocal. Cos theta will go to the numerator, sin theta will go to the denominator. This cos theta vanishes, so we can write 1 plus cos theta divided by sin theta. It means that 1 by sin theta plus cos theta by sin theta. So we can write here 1 by sin theta means we know cosec theta, while cos theta by sin theta means cot theta. That is cot theta. Yes, this is the middle side. Okay, dear students, so we can say first side equal to second side equal to third side. So we can write here square root 1 plus cos theta divided by 1 minus cos theta, that is equal to cosec theta plus cot theta equal to square root sec theta plus 1 divided by sec theta minus 1. Okay, dear students, so I hope you have understood the solution. This is proved of 2. Proof of 2. You have understood the solution of 2. Now I will show the solution of 4. Sec to the power 4 theta minus sec square theta, that is equal to 10 to the power 4 theta plus 10 square theta. So I will show that now. Six four. So we can write here left hand side is sec to the power 4 theta minus sec square theta. We need to show that this is equal to 10 to the power 4 theta plus 10 square theta. So we can write here, we can take sec square theta as common. So here will be sec square theta minus 1 if we take sec square theta as common. So now for the sec square theta we can write here sec square means 1 plus 10 square theta, and we know sec square theta minus 1 is equal to 10 square theta. So now if we multiply, you will get here 1 into 10 square theta means 10 square theta, and 10 square theta into 10 square theta means 10 to the power 4 theta. So we can write here 10 to the power 4 theta plus 10 square theta. So this is right hand side, this is right hand side. So proof is done. There, that means left hand side equal to right hand side. Proved. Okay dear students, I have done question 4 of 6. Now I will solve that last question of today, that is 7. Question 7. What is given? Given cosec A equal to A by B. Cosec A equal to A by B. Question 7 now. Given. So we can write here cosec A is equal to A by B. Now see what we need to prove. We need to prove here in the proof, if you see tan A equal to A square minus B square, here is square of A and square of B. So we can take the square in both sides. So we will get cosec square A is equal to A square by B square. We can write here squaring both sides. Squaring both sides. So we can write here cosec square A means 1 plus cot square A. 1 plus cot square A. We can apply the formula here, that is A square by B square. We can write as cosec square A is equal to 1 plus cot square A. This is the identity. Okay, so we can write here, cot square A, not theta, cot square A, that is equal to, we can take 1 in the left side, we can take 1 in the right side from the left side. A square by B square, it will be minus 1. Now calculate here cot square A. So we can write here A square minus B square by B square. Dear students, but we need to prove tan A. We need to prove tan A. How can we get tan A? Dear students, we can write here cot square A means 1 by tan square A, as we need tan A. For this we can write here A square minus B square by B square. Now we need tan A, so we have to take the opposite fraction. So we can do the operation invert and do here. We can write here tan square A, that is equal to, we have to take the opposite fraction. B square will go to the numerator and A square minus B square will go to the denominator. So now we can write here tan A, that is equal to plus minus square root. We can write here B square by A square minus B square. So if we take the square root from the, if we calculate in the right side, what will we get? this square of b and square root of b will vanishes. So in the numerator we will get plus minus b, and in the denominator a square minus square root a square minus b square will remain. So now see what we need to prove. Yes, we need to prove plus minus b by square root a square minus b square. The proof is done here. So we can write here proved. Okay dear students, so I hope you have understood our today's lecture. Keep practicing at home, abide by your parents, stay home, stay safe, see you again. Till then, Assalamu alaikum.